Okay, welcome back. One of the topics that we didn't really drill in, we mentioned it in passing, kind of, is the idea of subscriptions. So when we derived observables and observer from iterable iterator, we mentioned that in observable, for operational reasons, we wanted to be able to remove the observer from an observable when the consumer was not interested anymore in receiving more values. In this lecture, we're going to kind of drill in a little bit into the subscription type. Here's an example of earthquakes. So we have a stream of earthquakes, and we subscribe to this twice. Okay, so then we get back two subscriptions, S1 and S0. And the important thing here is that when we unsubscribe S1, so we remove the first observer here, that S2 will keep receiving earthquake notifications. But S1, or observer 1, I should say, will not receive any more. Okay? Now, sometimes we when we say subscription and unsubscribe, we mean cancel, or we say cancel, but that's not really the case, right? Because both the other one keeps receiving notifications. Now, together with this notion of subscription comes the idea of hot versus cold observables, and this idea is also present for iterables, but maybe it's not so apparent as with observables, but it happens there as well. So what is a cold observable? Well, a cold observable is when you subscribe to an observer, you get your own private copy of the stream. So in this case, because the way we implemented the code using retrofit, whenever we subscribe to the earthquake stream, we're creating a separate connection to the US Geological Survey service, and you will kind of keep receiving your own values. And that's called a cold observable. Another example of a cold observable is, say that you want to create a stream of random numbers. Now, every time you subscribe to that stream, you want to get your own copy of random numbers. You don't want to share the random numbers between the different subscribers. So one way to look at a cold observable is as an observable where the subscription causes a side effect. So you subscribe to a stream, you get back a subscription, and that function call will have a side effect. And that subscription kind of represents your own private copy of the stream. A hot observable is slightly different. And there you often think about UI events. For example, if you look at mouse moves, the mouse is moving no matter what. So if you subscribe to mouse moves, you're all kind of listening to the same underlying stream. And there, one way to look at that is that subscribing to that stream has no effect, because you're not getting your private copy. So your subscription is all shared together. In the jam sessions, we will show some concrete examples of this where you can see the difference. But for now, think of simple, when you subscribe to an observable, that subscribe action can have a side effect, in which case we call it hot, or it can have no side effects. In that case we call it cold. When it does not have a side effect, we call it hot. All right, so as I said, we often confuse the word cancellation and unsubscribing, but in general, when you have two subscriptions to one observable, and one of the subscriptions is unsubscribed, it has no influence on the other. So you're not canceling the underlying computation. And also, it depends on the stream. If the stream is hot, you don't want to, even if there's no subscribers, you might not want to kill the underlying computation, because later a new subscriber might come in and then you want to kind of catch on where you were. You don't want to kind of introduce yet another side effect. So these are all subtle issues when you're implementing your own observables to keep in mind. But again, there's no difference if you create your own iterables by implementing iterable and iterator directly. You have to think about all these issues as well. Okay, let's now zoom in into our subscription type. So subscription has two methods. Is unsubscribed, that you can check whether the subscription has been unsubscribed. And then there's a side effecting function here, the unsubscribe, that just kind of removes the observer that corresponds to this subscription. There's also a constructor for a subscription, so you can give it a nullary function that returns unit, that just does a side effect, and you get back a subscription. Now the interesting part of subscriptions is that they form an interesting algebra. Okay, so there's at least 3 kinds of subscriptions in Rx. The first one is a composite subscription, and that represents a group of subscriptions that is unsubscribed together. So you kind of pool all your subscriptions together, and when you unsubscribe the outer subscription, all the inner subscriptions get unsubscribed. The second one is the multiple assignment subscription, which is a subscription that you can kind of replace. It's called multi-assignment subscription, sorry. So you can replace the underlying subscription. And then there's the serial subscription, which is a special case of a multi-assignment subscription, but where you kind of when you subscribe another one, then the underlying subscription, the previous one, gets unsubscribed. Okay, whereas here it just gets swapped out. Let's look at a concrete example. I create a new subscription. I call unsubscribe. This will print bye-bye, I'm going fishing. When I call subscribe again, it will do nothing. So we assume that subscriptions are idempotent. So when you call them, the action happens once, then the subscription is unsubscribed, you call unsubscribe again, and nothing happens. And that's the reason that we have this unsubscribed state, because there's a big difference between a subscription that is still yet to be unsubscribed and a subscription that is already unsubscribed. But typically it's idempotent. All right, here's another example where we are kind of doing the same thing, but then we're printing is unsubscribed. In this case it will return false, and in this case it will return true. So after you unsubscribe, calling is unsubscribed will return true. Here's a simple example of a composite subscription. As I said, it's a group of subscriptions. So if I have subscriptions A and B, I add them to my composite subscription. I ask, are you unsubscribed? It says no, because it's not yet unsubscribed. Now I unsubscribe the composite, and now the inner ones will be unsubscribed. And what happens, you can ask yourself now, imagine that I have a composite subscription that's already unsubscribed, and now I add a new subscription to that, subscription C. What will happen? Well, the design choice we made is that when you add a new subscription to an already unsubscribed composite subscription, that new subscription will immediately be unsubscribed. Here it's, so that's kind of what happens. So if it's not yet subscribed, nothing happens. If it's already unsubscribed, it will be immediately unsubscribed. Here's an example of the multi-assignment subscription. We have a multi-assignment subscription that has A. When we swap it out for C, nothing happens to A. When we unsubscribe it, then again, when we add C to it, C will be immediately unsubscribed. And that's what we see here. And the last one, the serial subscription, as I said, is where you immediately unsubscribe the underlying subscription. So that was the algebra of subscriptions. In general, typically the subscriptions are used not in user code, but when you implement your own operators. And we will see later when we talk about the creation of observable sequences, there the notion of subscription comes in. But otherwise, what you typically get is, you subscribe to something and you get a subscription, and sometimes you combine them if you want to pass that around. But in general, this whole algebra of subscriptions is used inside other operators. All right, so this was a short, brief introduction to subscriptions. I invite you to play around with them. There will be a couple of exercises in the labs about them, and hope you're having fun. Thank you.